Hello, geometry, and welcome to the last lesson of Unit 4. We are back to proofs, and we're doing proofs with overlapping triangles. So the first thing I want you to look at is learning targets. Identifying shared sides and/or angles is key, and we're going to spend some time on that here at the beginning of the notes. Redrawing and accurately labeling two triangles from overlapping triangles is another thing that can be a very good tool to know. And ultimately, I want you to be able to prove that two overlapping triangles are congruent. All right, so overlapping triangles examples. Notice how in each of the diagrams below, there is at least one shared part between the two triangles. Identify that part or parts in each. So you're looking at number one. There is a part, an angle or a side that is shared in both. Okay, so in the first one, the shared part is angle B. Angle B, the full angle is in both triangles. I might have people who will say, oh, well, C is in both, but the angle C in one of the triangles is only that piece. In the other triangle, it's a full line. All right, so they're not the same angle C, so you can't say that angle C is the answer there. All right. Number two, what's the shared part? Hopefully you see that LP is the shared part. That whole side is in both triangles. Angle L is in both triangles. Again, I'm going to re-say what I just said on the last problem. Angle L is in both triangles, but in the triangle LPQ, it's little triangle. It's little l. In triangle PLM, it's the full angle. They're not the same angle L. To be a shared part, it's got to be the whole part. Okay, the whole line or the whole angle is in both triangles. All right, last one. There are actually two shared parts in this one. One of them is angle D, and the other one is side AB. Okay, so that's identifying shared parts. When you've identified the shared parts, you have one congruent part of the two triangles because of the reflexive property. We use that a lot in these proofs. You should be used to that one by now. Since you have a congruent part by the reflexive property, now you only need two more congruent pieces to prove the triangles are congruent. Okay, so if you can find the shared part, you're saving yourself a lot of trouble. Okay, flow proofs. Okay, angle T is congruent to angle R. How do I know that that's true? Well, it's given. Angle TPQ is congruent to angle RPV. So TPQ, so that's this angle here, is congruent to angle RPV. That's the same angle. It's angle P. That's the shared part. Those are congruent because of the reflexive property. PQ is congruent to PV. How do I know that? Well, it's given as well. Well, that's three parts, right? So now I should be able to say the two triangles are congruent. Can I? I can. Now this is the hard part. It's actually angle side. I'm going to tell you that. Okay. And then finish up the proof. How do I know that the angles are equal? Well, I could have actually said third angle theorem, but we'll say Cpctc here. Okay. Now back to this part. It's a lot of times very hard to see that in overlapping triangles. Okay. It might be a good idea to redraw the two triangles that you're trying to prove congruent. And that's what we're going to do here on the back. Okay. Now redrawing is great, but it doesn't necessarily help you. Redraw and label. Okay, so I'm gonna redraw what we had earlier. And it was T, V, P, Q, R, and S, and I had this and this and that and that, and then that angle. So we want to separate and redraw. Okay, so I'm going to draw PQ, T. So that's P, Q, T. So I'm just going to do the vertices right now. And then I'll go and do the other one, which I'll do it in red, show you. Okay. So we're looking at P, V, R. Now let's go through and mark what was given to us. So PV, which looks like it's on the triangle on the left, but it's actually here. PV is congruent to PQ, which is on the blue triangle. Angle T, which is on the blue triangle, is congruent to angle R, which is on the red triangle. And then angle P is in both. So it's congruent in both. Now it should be easy to see angle side. Okay, redrawing it helps you see why they're congruent. And it also might help you see the shared part. Okay, now that was redrawing, and I'm going to be doing that more when I'm doing these proofs. But I'm going to jump in and do these proofs. Okay, I'm going to go ahead and redraw that picture up here in this space. So I'm trying to prove QDA, so that's that one, is congruent to UAD, which is that one. So I'm going to redraw those two triangles. So QAD. And then I'm going to redraw in red UDA. Notice I'm not marking anything yet. There are things there, but I'm going to put them in my proof first. All right, so I'm going to go ahead and jump into the proof. First step, I'm going to say QD is congruent to UA. Okay. So let's go ahead and mark that. QD is congruent to UA. Right. Continue. How do I know that? It's given. There's another given there, and I can't say angle D because there's actually three different angles there. That's saying that the whole angle there, QDA, well, where do I see QDA? That's here, is congruent to UAD. That's here. Now I'm going to type that. Can't just put it on the picture without typing it. So angle QDA is congruent to angle UAD. Again, that's given. Okay, so there's two pieces though, right? That's two pieces of information that are congruent. That's good. Okay, what's my third? Well, these are overlapping triangles, right? Did we identify the shared part yet? No, we didn't. What is the shared part? Isn't it DA? Now, again, I'm not a huge stickler about this, but it is a good thing to hear and see. If you look at the congruent statement here at the bottom, DA is congruent to AD. It kind of gets flipped. So I'm going to use that to help me. Not UA. DA is congruent to AD. Why are those congruent? The shared part, it's the reflexive property. Now I can say that the two triangles are congruent. Triangle QDA is congruent to triangle UAD. Why? Hopefully you're catching that now. side angle side. And we've proven what we tried to prove. We're done. This one was a level 3 to 4. This is what you should be able to do on the test. Okay. Now, I am going to show you how it can take a pretty drastic turn to the more difficult here in a second. Okay. This one's level 6, 7, so it's not terrible. But it is harder. We want to prove that ED is congruent to CD. I can't mark them, but I'm trying to show you what we're trying to prove. ED is in this triangle, and CD is in this triangle. So let's start by redrawing those two triangles. Okay, so I'll start with the red one just because I have it up. So that's D, C, A. I'll do the blue one. D, E, B. And now I'm going to go ahead and mark what I was given. EB is congruent to CA, and angle DAC is congruent to angle DBE. All right, so let's go ahead and mark those, or we marked them. Now let's go ahead and type them in the proof. And just to show you that it does, I can do this in one step or two. I'm gonna go ahead and put both of them in there. EB is congruent to CA, and angle DAC is congruent to angle DBE. Reason that's given. Okay. Now, is there a shared part? Yeah, there is. Angle D is in both, right? Probably thinking this one's not too difficult. It actually isn't. This one's not too bad. It's the next one that's pretty bad. So angle D is congruent to angle D. I can say one letter there because there's no other angle D at all. That's the reflexive property. And now I have three things. I can say that triangle DCA is congruent to triangle DEB by angle side. And since that's the case, can't I say that ED is congruent to CD by Cpctc? And that's it. That one's done. Okay. So that one was actually probably more of a level of difficulty of like a 5 because you had to use Cpctc. But this one did have, what made it a little harder is I could have also had these overlapping triangles, right? But those didn't have anything to do with this problem. And I noticed that when I looked here. Okay. So the next one is where it gets really tricky. Difficulty level of 9. Okay. And I'm going to separate and redraw KMJ. So KMJ, that's that one. KMJ. And then LJM, that one. Okay. But what did I give you? I gave you KM was congruent to LJ, and LKM was congruent to KLJ. Now that's where it gets tricky. If you look at LKM, that's not one of the angles that I have drawn. I don't have an LKM in either of the blue or the red triangle. So what do I have to do? Okay, I'm actually going to go over here and I'm going to redraw the other two overlapping triangles. By the way, I'm not going to make you do this, but it is, I do want you to see how difficult they can get. Okay, so I'm going to redraw those as well. So that's K, LJ and KLM. Okay, so we still have KM is congruent to JL. That's still given. But now I do have angle LKM and angle KLJ. So angle KLJ is this one. LKM is this one. All right. So let's jump into the proof part, actually typing it. So I'm going to say KM is equal to LJ and angle LKM is congruent to angle KLJ. Okay. Now I want to look, I'm looking actually at the second set of pairs or second set I did up here, and I'm going to say KL is congruent to LK. Reflexive, right? Well, that allows me to say that triangle LKJ is congruent to triangle LKJ matches up with KLM. Why? I didn't mark those. Step 2, KL is congruent to, okay, that's side angle side. Now, what does that allow me to do? Well, it allows me to use Cpctc, right? And I can kind of pick what I want here. And what I'm going to pick is KJ is congruent to LM. So if I'm marking that, LM is congruent to KJ. Why would I do that? Well, KJ is also down here, and LM is also down here in the other set, right? In that other set down at the bottom, don't I also have a shared side here of JM is congruent to JM? That's the reflexive property again. Now I can say that the two triangles are congruent. Triangle KMJ is congruent to triangle LJM by side, side, side. Okay. I had to use a separate set of congruent triangles to make the ones that I needed to prove congruent. Again, I'm not going to make you do that on a test, quiz, anything like that. I might challenge you with a homework problem, something like that, maybe. But I just wanted you to see pretty much everything in use here. Okay. But stuff like number 1, the first proof up there, is I am going to expect you to do on your own. Okay. That's it for the lesson, and that's it for the unit as well. So, yeah.